Okay, we're going to review for the final exam. You guys have made it to the finish line here. We're going to do the final exam. There's 50 multiple choice questions. It's only multiple choice, and it should take about less than 2 hours to complete for you. So all multiple choice. So let's go over some of the topics so that you're ready to go for the final exam day. One topic on the exam is homogeneous versus heterogeneous. And so let's just describe these. Oops, genius. So homogeneous versus heterogeneous. You can find this list of topics on the, it says review for final exam in the module for the final exam, so you can see what the topics are. So homogeneous means versus heterogeneous means whether the thing you're looking at looks the same top to bottom, side to side. That would be homogeneous, like the same color top to bottom, side to side. And it looks exactly the same in any place you look in the container. That's homogeneous. If it's heterogeneous, you're going to see different things in the container you're looking at, like particles. You'll see particles or you'll see phases. So heterogeneous, you might see particles, or you might see two or three phases, where like maybe you'd have oil up here, water down there. That's heterogeneous, where you see differences. Homogeneous, it looks all the same. You just see all the same color, and there's no, you don't see any distinct particles. So that would be homogeneous. So a solution is an example of a homogeneous material. So a solution is, remember, we talked about molarity in solutions. A solution has a solute dissolved in a solvent. Solute is usually the small amount of something, and the solvent dissolves the solute, and it forms a solution. So that is homogeneous, because when you look at it, it looks the same top to bottom, side to side. An example of that in real life would be like Kool-Aid, where you dissolve the powdered Kool-Aid into water. Kool-Aid's a solute. The solvent is water. When you stir it all up and it looks the same top to bottom, side to side, the Kool-Aid solution that you drink, that's a solution, and it's homogeneous. Okay? So that's going to be one topic on the exam. There's also going to be questions about chemical and versus physical properties. So chemical properties is going to be a chemical reaction. So when chemicals come together and form something new, that's a chemical reaction. So if you had hydrogen gas plus oxygen gas, it forms water, liquid water. That is where atoms are bonding together and forming something new. That's a chemical reaction, and that's going to be a chemical property. So anytime you see a chemical reaction, that's a chemical property. It's how do atoms and molecules react. So that's a chemical property. Physical properties is when you have movement of atoms and or molecules. So when you have long hair, there's you, and somebody cuts it, that is a physical property. That's where you've moved molecules apart. Property. Anytime you're moving molecules or atoms, separating them from each other, that's a physical property. So if I have an ice cube, but I have an ice cube and I allow it to melt into a puddle of water, I've moved that structure of the molecules of water. Actually, if you looked at if you could see this on the molecular level, you'd see that water makes a little rings. Like there's a water here, a water there, a water there, a water there. It makes like a 6-sided crystal in ice. And so it has a particular distance between the molecules, and that's the crystal structure of ice. When you move those and separate them and change where they are in relation to each other, you're kind of breaking them down and turning them into water where they're closer together. That's a physical property. So phase changes are a physical property. So we talked about phase changes like ice to water, solid to liquid. We've talked liquid to gas, gas back to liquid. Those are all physical properties, and that's a physical change. So know the difference between chemical and physical properties. I'm going to pause here and I'll start up it again in a second here. Okay, the next big topic is Sig Figs on the test. So let's remember adding. Let's do an adding problem. So this has sig figs to the hundredths place. This one has to the tenths. So let's add them together. So that's my answer, but I have to round to sig figs. So remember, in adding, you round to the biggest place value that you had. So here you had the hundredths. Here you have the tenths, so I have to round to the tenths. So I underline the tenths place, and I look at what's after it, see if it's 5 or bigger. It's not, so my answer is going to be 1.3. Remember, always in your answers you're going to have a number and a unit. Okay, in all of chemistry we have a number and a unit. So in adding and subtracting, you look at the biggest place value and round to that biggest place value that you had when you look at the different numbers that you're putting together. Multiplying, dividing, say you're going to do so I'm going to put that in the calculator. My answer is this. Now on these ones we look at the number of sig figs. So this one had 1, 2, 3 sig figs. This one only has 1. So I have to round my answer to 1 sig fig. So I'm going to start on the left of all the numbers, not zeros, but the counting numbers. Counting numbers are 1 through 9. I look for the leftmost number in my answer, and I see that I have a 2, and then I can only have 1 sig fig, so I can only have 1 number showing in my answer. So I'm not going to call this, I can't just say 2 though, because this has a value of in the tens place, so I have to have an answer of 20 with no dot after it. If I put a dot here, that would make 2 sig figs, but I only want 1 sig fig. So I have to write just 2, because I looked at this number and it wasn't 5 or bigger. So I just have to put a 2, but I have to put a 0 there as a placeholder. So imagine this, like you look at your paycheck when you get your paycheck and they gave you $2 and you were really supposed to have $20, you're going to be upset. For example, $20 and you're supposed to get $200. So we can't just take off zeros or place values. We have to make sure that we continue how big the number is, but we just can't give a lot of numbers after it. We just have to give one number. So we have to say the answer is 20 with no dot after it. If I put a dot here, I've made 2 sig figs. Those zero rules are annoying and complicated, but we just have to make sure that we say that the size of the number, we keep the size of the number. We only write one sig fig to show, what that one place actually answer is. So zero rules, remember, like if I have zeros in the front of numbers, those don't count as sig figs. This only has one sig fig. Zeros in the middle of numbers count as sig figs. So this question right here has 3 sig figs. This one only had 1. And then zeros on the right of numbers, they count if I see a decimal somewhere. So I see a decimal here. So I have 1, 2, 3, 4 sig figs in this question. Okay, so sig figs are important, and it matters about the zeros as well. So zeros in the left of the numbers don't count. They're just showing how small the number is. Zeros in the middle do count. And zeros on the right of counting numbers count only if you see a decimal somewhere. Anywhere in the number you see a dot, that zero on the right of counting numbers counts. So this answer here is 4 sig figs. Okay? I'm going to pause for a sec and get to the next topic. Okay, so there's going to be some questions about unit conversions. So know what your different units are, like deci, milli, what they stand for. Oh, milli. So make sure you know what those all the different unit conversion, metric conversion prefixes mean. So like deci is 1/10, milli is 1/1000th, all those things. Make sure you know those for the test. All right. And then you're going to have some conversions for temperatures, Celsius to Fahrenheit or Fahrenheit to Celsius. So make sure you have those formulas for the test. So for, let's do Celsius to Fahrenheit is, you want Fahrenheit. So you're going to take the Celsius number. Sorry, I'm looking at my Celsius to Fahrenheit. I'm looking at the formula. Okay, so you're going to take 9/5 of the Celsius number and you're going to add 32. So say you had a Celsius of 100. You'd multiply by 9 and then divide by 5 and then add 32. So that would be 900 divided by 5 plus 32. I'll do that in the calculator real quick. So that would be 180 plus 32, and you get 212. Okay, if you want to go from Fahrenheit to Celsius, let's do that type. You're going to do Celsius equals the Fahrenheit number minus 32 first. Then you're going to multiply by that. So let's take the answer we just got, Fahrenheit 212. Let's see if we get the same answer back. So 212 minus 32, 180 times 5 divided by 9. Equals 100 degrees. So we got our answer back. So that's how you do the process of going from Fahrenheit to Celsius and Celsius to Fahrenheit using the formulas. I'm going to pause and start up the next topic. Okay, our next topic is density, and you might want to use the magic triangle on this if you like that. Remember, you can put your finger over the thing that you're looking for. For example, if I'm looking for mass, I can just put my finger over mass on that magic triangle and see that I need to do density times volume to get the answer. If I'm looking for density, I can put my finger over the D and do M divided by V. If I'm looking for volume, I can put my finger over volume and do mass divided by density. So the magic triangle is nice for that. Remember, the units for density can be grams per mil. They can be grams per cc or grams per cubic centimeter. Remember, cc just means cubic centimeter. So you're going to see those different units. And so your answer for mass would be in grams, and your answer for volume could be milliliters or cubic centimeters. They're equivalent to each other. All these things are equal to each other. So you can see any one of those in the answer, depending on the volume type of unit they give here in ml or cc or cubic centimeter. Okay, so don't let that bother you. Okay, let's do a classic density. So in the problem, they're going to give you a mass of, say, 31 grams. And then say they give you a volume of 213 ml. So this has 2 sig figs, and this has 3 sig figs. So my answer can only have 2. So I'm gonna find density. So I'll put my finger over density, and I'll realize that I have to do mass divided by volume. So I'm just going to put the mass as 31 grams, 2 sig figs, volume 213 milliliters, 3 sig figs. Do that in the calculator, and I get 0.14. I see a lot of numbers, so let me just double check, make sure I got the right answer. Okay, got this in the calculator, and remember, the calculator's done. You're the smart one. So I see tons of numbers here, but we said that we had 2 sig figs for 31 grams, 3 sig figs for 213 milliliters. So our answer, because we're dividing, can only have 2 sig figs. So I start with the leftmost counting number, which is the 1. Underline the 1 and the 4 because we want 2 sig figs in our answer. Then I look at this number here to see if I need to round, and I do, because it's 5 or bigger. So my answer is going to be 0.15, and my unit for density is gram per milliliter in this problem. Okay, so you can use that magic triangle to solve for anything. So we solve for density, but if I was given density and volume, I would just multiply them together to get mass. If I was given mass and density, I would take mass divided by density to get volume. So you can use the magic triangle to figure out density. Okay, so try some density problems before the test. So that's going to be on the exam as well. I'm going to pause for a sec and start the next thing. Okay, the next topic we're going to talk about is how to figure out protons, neutrons, electrons, and also write something in its isotope formula. So say the question said how many protons, neutrons, and electrons are in uranium-238. Remember, this thing here is the mass number for this particular isotope. And remember, isotopes can have different masses. So you can have different masses for a particular isotope. So that number can change even though the element is still uranium. Okay. So the first step on this question, they're asking for neutrons, protons, and electrons. And then they also want you to write this formula in the isotope way. So we're going to do that. So first you're going to look at the periodic table, and you're going to see that uranium is element number 92. And so remember that atomic number is the number of protons. And in a balanced element, when it's an element, not an ion, then that's the number of electrons. So 92 is the number of protons, because that's the atomic number. That's what atomic number means. And in a balanced atom, not an ion, it's also got 92. It's a number of electrons. They balance out in an atom. So in a balanced atom, the protons have to be have to equal the number of electrons. They're balanced. Okay. So lastly, we have protons, electrons, but we also want to know neutrons. So remember the mass of 238 is a combination of protons plus neutrons in the nucleus. It's the mass, because remember, electrons don't weigh very much. So 238 is protons and neutrons, but I figured out protons already. So if I take 238 minus 92, I'm going to get 146. So this is protons right here. So this answer has to be neutrons. So there's 146 neutrons in this particular atom, in this isotope of uranium. And remember, we write the symbol for these isotopes like this. We put the big number up top, the small number on the bottom. This is the atomic mass, and this is the number of protons, the atomic number. Okay, so we write it that way. All right, so this is going to be the same for all isotopes of uranium, and this top number can change. Okay, so that's how we figure out different isotopes of a particular atom. I'm going to pause and start the next topic. Okay, our next topic is groups, periods, and families. So we're going to need a periodic table. So here's my periodic table. Remember, periods go this way. So they're all stacked on top of each other. So period 1, 2, 3, like that. So that's the period. And these elements are adding protons and electrons and getting bigger as they go across the period. Now groups or families are on top here. So group number 1 goes straight down, and you have hydrogen stacked on top of lithium, stacked on top of sodium. These are group 1. These are a family, also called a family or a group, and they act the same way. And they're all in group 1, so they have valence electron on the outermost shell of 1. So group 1 has 1 electron, valence electron in its outermost shell. So hydrogen just has its nucleus. It has 1 electron circling it. Lithium has 2 shells, has a nucleus, has 1 shell. Then it has a second shell, and there's 1 valence electron in lithium. Sodium is in period 3, nucleus, 1, 2, 3, 1 valence electron. So all elements in one particular group, which is the same thing as family, have the same valence electrons. Okay? And remember, all elements are hoping to fulfill the octet rule. So remember, they all want to have a filled shell. So to feel like they have a full shell, for example, lithium would give away this electron here, and then feel like it has a full shell. Sodium would get rid of that valence electron, and then have 8 electrons in the outermost. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost shell to feel like it has an octet. So once sodium loses that 1 electron, it has a plus charge. So these guys are going to do whatever they can. This is the whole purpose of the periodic table. All elements want to have a full outer shell if they can. And so they're going to follow that octet rule. The elements on the left side of the periodic table are going to lose. Left are losers. They're going to lose electrons. The right side are going to gain electrons. They want to add electrons so they can get all the way up to 8 electrons in their outer shell. So the whole name of the game in chemistry is to get to that octet. They want to get to that full outer shell so they feel complete and stable. So that's the whole story of chemistry in one rule. Everybody wants to feel like their shell is full, and that's called the octet rule. Okay, I'm going to pause for the next topic. Okay, on the test you're going to have to be able to name ionic and molecular compounds, so that whole naming packet is what you need to review as well. Another topic is acids and bases. Remember, acids are a molecule. This is generic formula there, that give off H pluses. So acids give an H plus. Bases are going to give off an OH minus. So like sodium hydroxide, when it dissociates in water, it's going to give off an hydroxide, and the Na plus is going to break apart. This is a base. So anything that gives off an OH minus hydroxide is a base. Anything that allows an H plus to pop off of itself is an acid. Okay? So you're going to have to figure out how to calculate pHs. Remember, pH equals the negative log of the H plus concentration in the water. And remember, this bracket is molarity. Moles over liters. So sometimes the problem might just give you grams of something. You'll have to figure out molarity first, or it will give you the molarity. So let's say that I gave you molarity in the problem, and you were given a problem that says the molarity of an acid in water is 1 times 10 to the minus 5th molar. That's given to you in the problem, and they're asking for what the pH is. So you're going to plug that into the formula. You're going to put this number right there, put that in your calculator, and you're going to hit the log button on your calculator, and you're going to see -5 in your calculator when you're done with that. But then remember, the answer always has to be positive. So we're going to take the negative of the negative, and your answer is going to be 5. Okay? On pH and POH, I don't care about the Sig Figs, and it'll be a multiple choice, so you can choose the right answer. So don't worry about Sig Figs on these, because in log problems they're kind of weird. What if you were given the pH of 5 in the problem, and they asked you what is the concentration of the H plus? This is the question. We're going to work backwards now. You're going to put 5 in your calculator, put a negative sign in front of it. So put this in your calculator, put a negative sign in the front, so change it to -5, and then you're going to hit the second button and then the log button. It's called the anti-log. You'll see this on the top of the little key probably. You'll see log underneath it. This is the key we want. We want the second function. We want this function. When you do that, you're going to get this answer in your calculator. So try that, going back and forth between molarity to pH and then pH back into molarity to make sure that you can do that kind of problem. All right, POH is exactly the same thing. The POH formula is the same. It's POH equals the negative log of the OH minus the hydroxide concentration. So that's that. But just read the problem carefully. Sometimes on the quizzes we've done on pH, you didn't see that this was POH that they were asking for. So that's the hydroxide concentration, not the H plus concentration. If you were given pH, say of 3, and they're asking for POH, this is the question. Remember, pH plus POH equals 14. So if you know the pH is 3, and you don't know the POH, you can put it into this formula. So 3 plus something is 14. So POH is going to be 11. So remember that little formula too. That's helpful. Okay, so read the problem carefully to see if they're asking for pH or POH, and then solve using these formulas. Okay, I'm pausing for the next topic. Okay, the next part of our review is moles, atoms, and grams. So this is about molar mass and also Avogadro's number. Remember, Avogadro's number is 6.02 times 10 to the 23 particles equals 1 mole. So it could be atoms or ions or molecules making 1 mole. So let's say we have sodium chloride, and in the problem they give us 6.77 grams of this, and they're asking for the number of moles. So we're going to look on the periodic table and figure out they're asking for the number of moles. So that's the question. They give us grams and they want moles. So we're going to start with what we know. We know we have 6.77 grams. We know we have sodium chloride. And because I see grams and moles, I know in my mind that it's all about molar mass in this problem. So I need to figure out what that is. On the periodic table, it says that sodium, the molar mass for sodium is 22.99 grams. And they say for chlorine, the mass is 35.45 grams per mole. So use the periodic table I give you on the exam so that you come up with the same answer I have, 35.45. Then you won't be confused when you look at the multiple choice. All right, so if I put those together, that's going to give me the molar mass of sodium chloride, and I get 58.44 grams per 1 mole. Okay, so they gave us a mass starting at 6.77 grams. I need to get to moles over here. So I'm going to have to do a conversion factor. Remember, conversion factors, you want the thing you're trying to get rid of, which is grams, on the bottom. Whatever you're trying to get rid of goes on the bottom. And what you're trying to go to goes on top. So I'm trying to get to mole. So the molar mass is 58.44 grams in 1 mole. Remember, the definition of molar mass is 1 mole. Whatever the mass is for 1 mole. Okay? So I'm going to take 6.77 and I'm going to divide it by 58.44. And in my calculator, I get this. I get lots of numbers, of course, because calculator's dumb, but we're the smart ones. So in this problem, I had, it's always the number in the given, not the molar mass that you use for Sig Figs. So in this number, I have 1, 2, 3 Sig Figs. So I'm going to start with my counting numbers in my answer. There's a 1, and a 5, and then I look at this number to do rounding. So I do have to round upwards. So my answer is going to be 0.116 moles is my answer. Okay? So 3 sig figs. What if they said after that they wanted you to figure out the number of particles in that? So say they gave me moles in the problem, but I want to get to particles. So I'm going to use Avogadro's number in that case. So say I was given this in the problem, moles, sodium chloride, and they want to know number of these particles of NaCl. So when I see that I need a number of particles, I need Avogadro's number. So conversion factors, whatever's on the bottom, I'm getting rid, whatever's here, I'm getting rid of, and I'm putting on the bottom. So I'm putting mole here, and I want number of particles up top. So that's Avogadro's number. So 1 mole, definition, Avogadro number, 1 mole, particles. So in your calculator, remember you can use the EE key or the EXP or the up caret key. You're going to do 0.116 times 6.022 EE. Try to find out my calculator here. Wow, I haven't used, oh, here we go. I haven't used this calculator in a long time. Okay. 6.022 EE23 or up caret key or the EXP key. And when you do that, you should get this answer. So don't forget that you have you're going to see the little numbers on the right hand side of your display is your exponent. Some people have trouble with that. So make sure that you try this problem and you see little 22 over there on the right hand side of your display. Not saying this times 10 to the 22. They're just doing it in a shorthand way. Don't forget that. And get confused. So how many sig figs were in this problem? 1, 2, 3. My answer can only have 1, 2, 3. I look at the fourth number, and it is a 5, so I have to go upwards. So my answer with the right sig figs is 6.99 times 10 to the 22 particles. Okay, so that's how to do these type of problems. I'm going to stop for a sec, and we'll do gas laws. Okay, so we're going to talk about gas laws. One thing to remember is that 1 mole of a gas at STP, make sure you write down what STP is in your notes so you have it for the test. 1 mole of a gas at STP is 22.4 liters. So this can be a shorthand sometimes if you're given some number of moles and they're asking what volume that is. So say I have 10 liters, 13 moles of a gas. It doesn't matter what gas it is. At STP, they give that to me in the problem. They want to know how many liters that is. Well, I can just use that conversion factor really quickly, so I don't have to do P1, V1. I don't have to use PV equals nRT or anything like that, if I know this little shorthand conversion. So, if I have 13 moles in the problem, I know this is working, that little shorthand is okay to use, and I'm trying to get rid of moles, so 1 mole goes on the bottom. And I use 22.4 liters on top. That's going to cancel out the moles and give me volume. So if I do that in the calculator, I do 13 times 22.4. I'm going to get this many liters, 291.2 liters, 2 sig figs. 2 sig figs, I'm going to write 290 liters as my answer. So this little shorthand is good if you're going moles to liters or liters to moles, if you see that you're at STP. So that's a little shortcut. If you don't have those things in the problem and you see a change in volume or temperature, you see any changes, that means you're going to have this formula. If you see changes in temperature or volume or pressure. How do you know if you're seeing that? Well, in the problem, you can make a little table like this. And you could just fill this in when you're doing the problem and see what you fill in. So if you see that, one big clue is if you see that you have a number of moles, then you're probably going to have to use this formula, because this formula has number of moles in it. If you're seeing one pressure and then a second pressure, like 2 atm, make sure you know your units too. So pressures in atm or torr. So know all those pressure units. And then you see a second pressure in the problem of 3 atm or torr or something like that. Then you're going to use this formula here. Okay. If you only see one pressure or one volume or one temperature, and you see also, or you're asking for moles or grams is a clue that you're going to use. If you see this in the problem, you're going to use this formula. If you see changes, you're going to use this formula. So that's the clue to figure out which formula to use. That's also, I've noticed that some students have problems figuring out which formula to use. So make sure that you maybe write a little chart like this to see what's going on. If you see changes from one thing to another, like pressure or volume or temperature, use that P1, V1, T11. Okay. So say they gave me this pressure of 2 and then it changed to 3, and say they gave me a temperature of 10 degrees and they want to know this guy. Well, remember, gas laws always have to be in degrees K, so you always have to add 273 before you even start these problems. This is another big place where people forget to do that, and then their answer's wrong. So make sure you add 273 to any degree Celsius problem before you start. So I see that there's changes in pressure in this problem, and I see that they're asking about temperature changes. So I'm going to use this formula here, and I'm not going to worry about volume, so you can just get rid of that and use the formula P1 T1 equals P2 T2. Then I'm going to throw the numbers in that they gave me. So they started with 2 atmospheres for pressure. They started with 10 plus 273 is 283 degrees K. Has to be K. This is where people mess up. You can't have Celsius in this formula, though. It doesn't work out, right? And they're changing to 3 atmospheres pressure. This is my unknown. This is my X. Then I'm going to cross multiply. And I'm going to get 2 times T equals 3 times 283. I'll put this in the calculator. So my calculator, I'm going to do 3 times 283, which is 849. So 2T equals 849. Then I'm just going to divide both sides by 2. I'm going to get T2 is 424.5 degrees K. And then we have to think about sig figs. So in this problem, 2.0 is 2 sig figs, 3.0 is 2 sig figs, 10 is 1 sig fig because I didn't put a dot after that 0 there. So my answer can only be in 1 sig fig. And I can't say just the answer is 4 because that wouldn't be true. That's not the size of that number. It's like if I got a paycheck of $4 and I was supposed to get in the 400s, I would be really upset. So my answer has to be in the hundreds place, but it can only show 1 sig fig. So my answer is going to be 400 degrees K. No dot, If I put a dot, that's going to be 3 sig figs. So only 1 sig fig, but it has to be in the right size that I'm looking for. So my answer is going to be 400 degrees K. Okay. So the place people have trouble is making sure they always change C to K, so add 273. The other problem I see a lot is where people, maybe there's 2 different pressures or 2 different volumes, like a milliliter versus a liter. Make sure you're in the same units on both sides. That's really important. So temperature is where I see the most problems. Sometimes people don't have the same units in different places. And then if you're using PV equals nRT, make sure you're looking at what pressure unit you're in, and then choose the right R for that. And then the other problem I see on PV equals nRT is people don't put that in K. So it has to be the right R value. There's different R values based on the pressure you're in. So make sure you have all the different R values written down before you start the final exam. And then temperature, people forget to put that in degrees K. So those are the things you need to know for gas laws. So I'm going to pause and start on to balancing equations next. Okay, our next topic is balancing equations, mole ratios, limiting reagents, and like gram to gram problems, gram to mole problems, things like that. So we're going to do equations now. So let's do balancing first. Let's say you're given this in the problem, H2 gas plus O2 gas forms liquid water. So if the question's asking about balancing or asking for looking at one molecule and figuring out how much grams or moles are formed of something, then you have to balance the equation first. That's super key. So let's look at this. Is this balanced? I see 2 H's here, 2 H's there. Balance. That's good. Left and right have to balance. If there's no numbers in the front of the formula, then assume that it's a 1. So 1 times 2 is 2 H's. I see 1 times 2 is 2 O's, but on the right side, I only see 1 O. 1 times 1 is 1. So for this formula, the O's do not balance the oxygen. So I'm going to put a 2 in front of this. So 2 times 1 is 2 O's. 1 times 2 is 2 O's, so that balances. But now I've done 2 times 2 is 4 H's, and that does not balance. So I need to put a 2 here, and then everything balances. I see 4 H's here, see 2 O's here, I see 4 H's here, and 2 O's here. So this balances now. Say, in the problem, they're asking for what the limiting reagent is. You have to balance first, which we just did, and then say they gave me, let's say they gave me 10 H's here. They said there's 10 H's in this particular container I have, and they gave me 20 O2 gas particles in the container as well, and they want to know which one of these is limiting how much water I make. So this is a limiting, you might see the word limiting reagent or reactant in the problem, and they want to know what's limiting me. Is it this guy or is it this guy keeping me from making as much water as possible? So that's a limiting reactant problem. So if I look at it, I need twice as many H's as I need oxygens. And I have the opposite in this problem. I have lots of oxygen and I have very little hydrogen. So my limiting in this is going to be the hydrogen. It's keeping me, this guy is my limiting reagent or reactant because it's keeping me from making enough water. You could figure this out mathematically if the numbers aren't so easy like this. So let's try one of those. So I can figure out how much water I can make just given this information. So say they gave me 10 hydrogen molecules, and I want to know how much water I make. I can use the mole ratio of this to figure out how much water I can make. And knowing 2 and 1 and 2, I can figure out how much water I can make. So if I have 10 hydrogens, the ratio of hydrogens to water is a 2 to 2 ratio from the balanced equation. Remember, this is a mole ratio. This tells me how much water I can make. If I have 10 hydrogens, if I do the math, 10 times 2 is 20 divided by 2. I'm going to make 10 waters. Okay? Okay, so that tells me how much water I can make if I have 10 hydrogens. Let's see how much water I can make if I have 20 oxygens. The mole ratio for oxygen to water is a 1 to 2 ratio. So in this case, if I had 20 oxygens, I could make 40 waters. So like I said, hydrogen in this case is my limiting, because if I have 10 hydrogens, I only make 10 waters. If I have 20 oxygens, I make 40 waters. So that's called a limiting reagent problem. Remember always to balance the formula first. Let's say instead of a limiting reaction kind of problem, they are giving me grams of one reactant, and they want to know how many grams of product I can make. So remember, it's a 2 to 1 to 2 ratio. And say they gave me 13 grams of hydrogen, and they want to know how many grams of H2O can I make. So if I have 13, I'm going to start with grams of hydrogen, and I know I want to get to grams of water over here on the right side. This is a gram to gram problem, so there's 3 steps. We're going to do molar mass first. We're going to do mole ratio next. We're going to do molar mass next to get the answer. So I want to get rid of grams of H2 and figure out moles of H2. So if I look at the periodic table, hydrogen is 1.01 gram. So 2 of them is 2.02 grams. Now I want to go from moles of hydrogen. Oh, in molar mass, there's only ever 1 mole. So don't mess up there. That's where people mess up. Molar mass is always 1 mole. Okay, now I want to go moles of H2 to moles of water. Looking at the balanced equation. So balanced equation, there was 2 moles of H2, 2 moles of water. So it's a 2 to 2 ratio in the balanced equation. Last step, I want to get from moles of H2 to grams of H2. So molar mass, definition of molar mass is 1 mole of water. This is where people mess up. Don't look at the balanced equation in this step. Only do definition of molar mass as 1 mole. And I want to know the molar mass of water. So it's 16 for oxygen and 2.02 for the 2 hydrogens. So it's going to be 18.02 grams. Water, oxygen is 16. 2 times hydrogen is 2 times 1.01. So when I get it all together, it's 18.02. All right. And now I'm where I want to be, grams of water. And then you do the math. So you do in your calculator, I would do 13 divided by 2.02 times 2 divided by 2 is really just 1. And then multiply by 18.02. In my calculator, I get 115.97 grams water. And I have to double check. I'm going to double check in my calculator to make sure I did this right. Yes, so I got that in my calculator. And then I have to think about Sig Figs. There was 2 Sig Figs in the problem given. And I have to go to 2 Sig Figs. So I can't say my answer is 16 because that would be like the paycheck problem when I'm supposed to get $115 and I say I'm only going to get $12. So I still have to keep how big the number is. So in this case, I'm going to say my answer is 120, no dot. 2 Sig Figs, okay? So that's how to do a gram to gram problem. Sometimes they're going to ask gram to moles, so you just get rid of that step. So look at the different types of stoichiometry problems. I know those are probably the most difficult that we've had this year, so maybe just have those types, how to do each of the types of stoichiometry problems written down for yourself so that you're ready to go for the final. Okay, I'm going to go on to molarity next, and then we're almost done. Okay, next is molarity. Molarity, big M, is moles over liters. It has to be in liters, can't be milliliters. So if you see milliliters in the problem, change it. You can use a magic triangle for this one too. It's moles divided by liters is molarity. Put your finger over the thing you're looking for in the problem. If they give you molarity and liters, you can multiply them together to get moles. So say you're given, you're looking for moles, you can put your finger over the moles and do molarity times liters. Say you're looking for molarity, put your finger over the big M, and it's going to be moles divided by liters. Say you're looking for liters, put your finger over the L, it's moles divided by molarity. So let's try a simple problem. You might be given grams and you have to change to moles first, and then you can do molarity. So let's keep it simple in this problem, but if you see grams, then change it to moles first before you start. Okay. So say they want the molarity of 32.3 moles of HCl. And they're giving you also 63.77 liters of water. Of the solution. And they're asking for the molarity. So you have moles and liters. You're looking for molarity. Put your finger over the big M there on the triangle, and it's going to be moles divided by liters. So we'll just divide these two things together, and that's going to give us big M. So let's do it in the calculator. We have 32.3 divided by 63.77, and I get this in the calculator. But I can't use that as my answer because this was 3 Sig Figs here, and this is 4 Sig Figs there, so I can only have 3 Sig Figs in my answer. 0 doesn't count as a Sig Fig. Here's a counting number starting on the left. 1, 2, 3. Look at the fourth number. We have to round up. So our answer is going to be 0.507 molarity. Okay, so make sure you can use that magic triangle to figure out molarity or moles or liters. Make sure you're in liters, not milliliters when you do the problem. Really important. Okay. All right, that's enough for molarity. And then also remember you can use this formula for a titration problem or a dilution problem. If you see something where they have a particular molarity and a volume of a solution and they add more water to it, it's going to be this dilution kind of problem. If you see the word dilution or adding solvent to a problem, then you're going to use the M1V1 equals M2V2. Or if you see a titration problem, you can use the M1V1, M2V2 like we had in the titration lab. And I did a little video on how to use this formula in that titration module when we did titrated vinegar. But in these problems, they're going to give you maybe they'll give you a molarity M1 of 3.25 molar, and say they give you a volume 1, of 1.2 liters. You can use liters or milliliters in this problem as long as you're the same on both sides. So that's the only time when you can use this. You can use either milliliters or liters. So say they gave us that, and they gave us a new volume of 1.7 liters. So they've added some solvent to it and they've diluted it in this problem because now they have a bigger amount of volume. So this, when we do this math problem, we should get a lower molarity because they've diluted this. So it's just like if you have Kool-Aid and you need to stretch it because your kids are drinking it too fast, you can add a little water to it. It's going to make the flavor less, but you're going to save the money. So my molarity should go down. I'm going to have enough drink for all the kids. Okay, so I'm diluting this Kool-Aid down. My strength should be lower, and I'm going to save some money, and I'm going to make sure I have enough for the kids to drink. So if I multiply these two numbers, I get this number. Now I'm going to divide both sides by 1.7. And now my molarity is 2.29. This is what I see in the calculator. I have to do Sig Figs, so in this problem there's only 2 Sig Figs. It's my smallest Sig Figs. So my answer is going to be 2.3 molar. It started at 3.25 molar, so it was concentrated, and then it's more dilute, so my Kool-Aid is going to taste less Kool-Aid-y, less strong, but I'm going to have enough volume for all the kids in the neighborhood to drink. So that's a M1V1 equals M2V2 problem where you're diluting it. So if you see the word dilution or you add solvent to the problem, you can use this M1V1, M2V2 problem. Okay, I'm going to pause for the next one. Next topic is redox. So redox means that something has become oxidized or reduced. That means it's had more electrons added to it or it's lost electrons. Remember when we balanced this, we put a 2 here to make the oxygen balanced, and then we had to put a 2 there to make the hydrogens balanced. But now we're talking about what oxidation number do these elements have. So by definition, any element all by itself has an oxidation number of 0. So hydrogen bonded to itself, definition, oxidation number of 0. Same with the oxygen. Any element, if it's just written by itself or if it's bonded together with itself, then it's got a definition, oxidation number of 0. Then we look at this molecule. And this is where the periodic table helps us. We know that hydrogen is in group 1, so its charge is generally +1. Oxygen's group 6, so its oxidation number is -2 because group 6 want 2 more electrons to fill its octet. So we have group 6s are generally their oxidation number is -2. To make this balance out, I have 2 H's that are each +1. So this side of the molecule is a +2 oxidation number. Balances out the one oxygen is -2. And I see that my overall charge for this molecule is 0, which is what I'm looking for. This molecule has a charge of 0 overall. If something had a charge, an overall charge, you would see like this. This ion has a overall charge of -2, and then you'd have to do oxidation numbers to figure out that this overall guy has a -2 charge. So let's try this guy. When I'm done, this thing has to have a -2 at the end. So oxygens, each one is -2. I have 4 of them, so -8. So this sulfur has to have a +6 charge in this situation. +6, -8 makes -2. So the rules to remember are H usually has a +1 and oxygen usually has a -2 charge. Also look at the periodic table for what group they're in, and that will help you figure out the charges. Now let's look at this redox equation again. I had H2 going from 0 to +1. I had oxygen going from 0 to -2. So the element that it goes towards a more a lower number is reduced. So this went from 0 to -2, so it's got a lower number now. So the oxygen is reduced, and the H went from 0 to +1, so it became bigger, so it's oxidized. Okay, oxidized. Hope I spelled that right. And this guy's reduced. Okay, so that's redox. Okay, one more topic and then we're done for the final exam review. I'm going to pause for a sec. Okay, the last topic is bonding and with carbon, what carbon does. Some of the types of molecules it makes. So look at that whole hydrocarbon packet that we did. There's a lot there. But know the basics, like that carbon always has 4 bonds to it. So it's always going to have 4 lines associated with it. It may be a double bond or a triple bond, but there's always 4 lines that are hooked to the carbon. So in this case, you could have a simple hydrocarbon like methane. And there's carbon there with 4 single bonds. This is a tetrahedral shape. It looks like a big pyramid shape if you looked at the carbon and then looked at the hydrogens attached to it. I can't draw in 3 dimensions, but it looks like a triangle in 3D. So that's the carbon in the center hooked to 4 things on the outside. Carbon also can double bond with things, so you can have another carbon. And if you notice this drawing, each carbon only has 4 bonds attached to it. That's where some people are having trouble in hydrocarbon chemistry. They're drawing too many lines on the carbons and messing up their formulas and stuff like that. So always look for only 4 lines hooked to the carbon. And it's best if you draw things out, then just try to write formulas like this would be CH2. It's hard to just think about that in your mind without drawing it, so draw it first. Carbon can also triple bond. So each carbon is filling 3 bonds already, so they can only have 1 hydrogen left over. So the formula for this is C2H2. Okay? So make sure that you that you know that carbon only has 4 lines attached to it. Know some common molecules like the alkanes, how to name and what they look like. Alkanes, alkenes, alkynes. Know those. Also know some other simple ones like the ether shapes, the carboxylic acids, ethers, aldehydes. Look at the more simple ones in the hydrocarbon packet. That would really help for this test. All right, you've learned a lot in one semester. I know chemistry is not easy, and you've prevailed and persevered through the whole semester. I'm super proud of you. Please take all this and get your notes together for the final exam. I know chemistry is not easy, and you've done really well. So pat yourself on the back, even though I can't see you now. But just assume that I'm congratulating you on doing such a great job this semester. It has not been easy. Chemistry is just generally not easy. It's like another math class. I kind of think of chemistry as a math class in a foreign language. So you've learned how to learn vocabulary and a new vocabulary, and then be able to use that vocabulary in math formulas. So not easy, and I'm super proud of you. So good luck on the final, and congratulations on finishing. All right, talk to you later. Bye-bye.